This is section 5.2, day 1, and today we're going to talk about perpendicular bisectors. Perpendicular means meet at 90 degrees, and bisectors means cut in half. So we've got some things that are meeting at 90 and cutting in half. They're doing two things at once. So a perpendicular bisector, again, meets at 90, creates that 90-degree angle, and most of you know that when you have a 90-degree angle on one side, then you automatically get to have it on the other side. And the bisector just means that you're cutting it in half. So you're creating two parts that are equal, okay? So a segment, there's a lot of things that could cut it. A ray, could be a line, or even a plane that is perpendicular to a segment at its midpoint. So kind of everything we just said in smaller words. You have something cutting through a segment, makes a 90, and chops it in half. Equidistant, this might be a new word for us, but we also have equilateral and equiangular we've talked about. So this shouldn't be too hard, just equidistant. So a point that is the same distance from two figures. It's usually points we're talking about. We're usually talking about a point being equidistant from two things. That's usually where you're going to see the word equidistant. Okay? Perpendicular bisector theorem. This is the one theorem we're going to use in this particular section. It just says that a point is on the perpendicular bisector if a point is on the perpendicular bisector, then it is equidistant from the endpoints. So if I know that C is on the perpendicular bisector, so if I know that it makes a 90 and gets cut in half, and C is right on there, could pick any point along the way, then if I draw lines to the segments, to the endpoints, I know that those are equal. These guys are equal. So anywhere along there where I decide to draw a line down to the endpoints, those two segments I make are going to be equal. So let's do a couple of examples. Sorry, wrong page. Oh, one theorem, converse. So we're just going to flip it now. So the converse just says if a point is on the perpendicular bisector, if a point is, I just read the same one. If a point is equidistant, we got to flip it from the endpoints. Then it is on the perpendicular bisector. So if I know the information in reverse, if I knew that D was the same distance from B and from A, so if a point is equidistant from both endpoints, then that makes this guy a perpendicular bisector. So you kind of get some extra information out of the picture. So you start with just one thing, knowing that D is the equidistant from both of them. Then that makes that guy be the perpendicular bisector. So it's a lot easier than it sounds in words. And we'll try a couple and you'll see how they're pretty simple. So BD is the perpendicular bisector of AC, so I'm going to mark some stuff. Those are equal, and that's a 90. Find the length of AD. If AD is on the perpendicular bisector, then it means these guys are equal. So 3x plus 14 equals 5x. Minus our 3x over and get 2. And then x is 7. So they said find AC, so all I'm going to do is just plug it back in there. Whoops, AC. Oops, I bet I meant that. Oh, 80. There we go. So put a 7 in there, so you get 35. In the diagram, WX is the perpendicular bisector of YZ. Will WX pass through V? So if this is the perpendicular bisector, I know those are equal. If V is going to be on this perpendicular bisector, then these guys have to be the same thing, and they are. So it will pass through point V. If this guy had been like 26 or 24, if it wasn't the same, then it wouldn't pass through V. It would just be off kilter a little bit. Last one in this diagram, JK is perpendicular bisector of NL. So JK to NL, they did mark the 90. I'm going to mark that. And then they say solve for X. So if that's true, if that much information is true, then I know that K is the same distance from L as it is from N, which means that guy is equal to that one. So 6X minus 5, 4X plus 1, minus my 4X over, add my 5, and divide by 2. Okay, and that was just a solve for X, no plugging it back in. The whole thing about bisectors is being able to set things equal. We're talking about a segment that goes right up the middle and kind of cuts everybody in half. These two are equal. The 90s are there. These two guys are equal. So it creates a lot of equal parts when you have a perpendicular bisector.